Let's begin. Today is June 17th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 5 criteria cards. Criteria card 1, 10, 18, 19, and 20, and uses the blue verification cards. The code above is your way to get more information on today's puzzle on turingmachine.info. Let's solve. So on the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. And on the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at the first digit, the triangle digit, and will compare that number to 1, essentially. Either it's equal or the triangle value needs to be greater than 1. Criteria card B looks at our 3-digit solution and will let us know how many of those 3 digits are 4. Are there no 4s? Is there a single 4? Perhaps 2? Maybe even all 3 are 4s. Criteria card C looks at all 3 digits, triangle, square, and circle, adds their values, and the Turing machine will let us know whether the sum should be an even quantity or an odd quantity. Criteria card D will take a look at the first 2 digits, add them up, and compare their sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will look at the 3 digits and will let us know a little bit about how it's structured. So is it that there are no repetitions among the 3 digits, meaning that they're all unique, as in the example 125? Could it be that there's a double number, a repeating digit, as in the example 112? Or is it a triple number, where it's a single digit repeated 3 times, like the example 222? Remember, our objective today is to find this unique 3-digit solution that abides by all the criteria cards that we discussed right now. So we're going to start off with our initial proposal of 314, and the first thing I want to test is I want to know what the sum of the 3 digits is. So let's go ahead and test criteria card C. Okay, so the Turing machine responds that it does not approve of the proposal I have with respect to criteria C, where we add up the digits. So if I add up my 3 values, 314, 3 plus 1 is 4, and 4 plus 4 is 8. That sum is an even quantity. The Turing machine does not approve of that, so it's basically telling me that the sum should be odd. So let me go ahead and write that up in my notes in section C, that the sum of triangle plus square plus circle should be an odd quantity. Okay. Well, all that really tells us is that we could have a pair of digits, which we will soon test, but that third number needs to be an odd. And I'll explain a little bit about it more in case we do have a double. I'm anticipating that there might be. So that is criteria card E. So let me go ahead and test it. Oh no, okay, so there is not. Okay, so maybe it's a different situation. So the Turing machine does approve of my 3-digit code, 314, with respect to criteria card E. And since all the digits in my proposal are distinct, it is confirming that yes, there are no repetitions. So that is criteria card E. And so let me go ahead and put that down in my notes, that there are no repetitions. Okay, so if there are no repetitions and they're all unique, um, I guess sort of yeah, it's not that there's a double number, but basically what's happening is either I've got two evens and an odd, or they're all odd. The reasoning behind that is that if you have two digits that are even and you add them up, well, that sum remains even, but you need that third number to be an odd in order for the final sum to be odd. Similarly, you could have all three digits be odd. So I'm going to put in an extra note here that either two evens or all odd. Okay, so obviously if there's two evens, that means the third one's an odd, and of course all odd means all odd. Okay, so so now that I know that either I have two evens and an odd, or they're all odd, maybe this might be a good criteria card B might be a good test to query the Turing machine. Remember, if they are all distinct, that means there can only be one 4. And if there is a 4, that means that the other even has to be distinct, which means that it must be a 2. So let me go ahead and test criteria card B. Okay, so notice that in my proposal I do have a single 4. The Turing machine does not approve of that, so that means that technically there is no 4. So of course there can't be three 4s, because again the sum needs to be odd. There can't be two 4s because criteria card E told us that there's no repetitions, and so it comes down to either there is a 4 or there isn't. And since there is no 4, that means that in fact they're all odd and they're all distinct. So let me go ahead and put down my something in my notes here, that there is no single 4. But as I explained, there should be no 4s altogether. And so let me get rid of this either two evens. So we know that they're in fact all odd, which means that, and since they're distinct, they have to be 1, 3, 5. So that means that I can confidently cross out all the evens. So very interesting how these three criteria cards, and sort of, I don't know if it has anything to do with my initial proposal of 314. I'm assuming I'd get the same sort of responses and therefore the same conclusions, but I'm not sure. But it's interesting how these three cards, B, C, and E, kind of work together, and we end up discovering that, wow, all the three digits are odd and they're all distinct. Very interesting. Okay, so we already concluded our first round where we tested our three criteria cards. We're now going into the phase where we're sort of thinking through how to construct a good second round proposal. And basically, it comes down to criteria card A, which is again looking at the triangle digit and comparing it to 1, whether it's equal or greater than 1, and the sum of the first two digits. Okay, so in essence, notice that criteria card A and D have nothing to do with circle. So somehow circle is going to be forced into one of these three odd digits. That's it's going to kind of fall to it. And so one possibility is that maybe the sum is of the first two numbers, triangle and square, It could be that the sum is 6, which would mean that it's a 1 and a 5, and therefore the circle digit ends up being 3. That's definitely viable, but you could also maybe have them add up to be, less than 6, which would be 1 and 3, or greater than 6, which would be 5 and 3. But let's actually talk about that, since I do have a card that says it's equal to 1. So if it's equal to 1, then it could be a 5. If the sum is 6, that would work out. If it's greater, then I would almost imagine it's not going to be 6. It's either going to be less than 6 or greater than 6, which would mean that perhaps it'd be like a 3-1, or if it's greater, I think maybe greater might not even work. What would that be like? If it's greater than 6, the only possibility is 3-5, and if I know that the triangle is greater than 1, which one is it? Is it 3 or 5? So I don't think the sum, I think I can deduce that the sum cannot be greater than 6, because I can't really distinguish between 3-5 and 5-3. I just don't see that. Of course, circle will be 1, but I think that would give us too many ambiguous solutions. So I think it's going to fall to either less than 6 or equal to 6, but I'm going to go with equal to 6. And I'm going to say, let's see, if it's 1 and it's equal, I'm going to go with 153. Let's go with that and see where that leads us. Okay, so let's go for it. Okay, so yes, first thing I want to test is, let's see, is there a benefit to testing one or the other? If I know it's 1, I still don't know if it's less than 6 or equal to 6. If it's equal to 6, you could say it's greater than and then 1, or you can say it's 1 and then it's going to be 5. I don't think we can really deduce that. So let's go ahead and just test criteria card D and confirm the sum. Okay, yes, so indeed it is equal to 6. So, and that is criteria card D. So let's go ahead and type that up. That triangle plus square is equal to 6. And so notice that because the sum is equal to 6 and they are all distinct, triangle and square cannot be 3s. So we can say that much. Even though 3 plus 3 does equal 6, but since they are distinct, we can have them be 3, and so therefore also we can cross out the 1 and the 5. Now, actually, I may be getting ahead of myself by crossing all this out, but I feel confident that yes, it's going to be 1, 5, and then that means that the circle must be 3. Okay, so the sum is 6, so it's either 1 or 5, and so let's go ahead and verify what triangle is. At this point, it could be either or, to be honest. So that's why it's a 50-50, and we just have to confirm A. Okay, so it does not approve of my proposal where triangle is equal to 1, so therefore triangle needs to be greater than 1. So let me go ahead and write that in my notes for criteria card A in section A. That, triangle must be greater than 1. So that means that, triangle is not a 1. And so it must be a 5. And so that forces square to be 1, since the sum has to be equal to 6. And so basically that's our solution. It's 513. Okay, so let's take a look really quick. Yep, if triangle is greater than 1, yes it is. There's not a single 4. The sum is odd. The sum of the first two are 6. And there are no repetitions, and they're all odd. So that looks great. So let's go ahead and go to turingmachine.info to verify. All right. So let's test the code. And it was 513. Okay, excellent. So we got it, but of course we have to confirm, or we have to verify how we did versus the Turing machine. I do believe that since there are 5 criteria cards and I tested I just had 5 tests, that I'm confident that I'd at least matched wits with a Turing machine, and but we'll see if we tied or not. Okay, so in the first turn we did B, C, E, and both B and C were incorrect. So let's go ahead and type that up. So B, C were incorrect, E was correct, and in the second round A was incorrect, but D was correct. We tested one of each. Let's see how we did. Okay, so we did beat the Turing machine by 1 question. We both did it in 2 rounds. So great. I think, like I mentioned, the first round really went well. Our deductions really helped us to get a good feel for what the 3 digits could be going into the second round, that they were all odd. And so I think that really gave us an advantage. Well, let me know what you think. Please do add a comment, and if you did like the video, please do give it a thumbs up so that other people can find this channel. And if you don't want to miss out on any future videos, please do hit subscribe to be notified. Well, until next time, have a great one.